The Booker T. Washington Housing Project is a public housing site in Jersey City. We have only about 30% through this resiliency master planning effort that we've been doing with the Enterprise Foundation and Jersey City Housing. Next. So for those of you who don't know the location, the Hudson River is here. This is the Jersey City waterfront. That orange dot up there is the Booker T. Housing Washington housing site. And what you'll see is that the Morris Canal and Mill Creek wrap around and come within less than a quarter of a mile of the Booker T. housing site. What that meant is that during Superstorm Sandy, parts of the site experienced 5 to 6 feet of floodwaters. Basically, there were rescue boats going around the streets of Booker T. Washington during that event. The dots are actually part of a year-long study we did with Stevens Institute of Technology, looking at water flows in the area and doing a resiliency plan. Next. But you can see this is lower scale campus style housing. There are actually wonderful mature trees on the site. We did a great walking tour with the residents who really told us a lot about anecdotes that really went and reinforced our digital analysis of the site. Putting those things two together were absolutely critical. The residents were fabulous. Next. And what we learned is that there's really two types of flood events on this site. So if you're looking at a side view of the public housing site, the first event that you get is a rain event, a heavy rain event. All of the rain that lands on this property basically is collected into a series of pipes. The pipes do not have the capacity, the well-known combined sewer system doesn't have sufficient capacity for these major heavy rain events. So you get localized flooding on the site, and then you get the water, so much pressure of it, that the water is actually backing up into the first floor plumbing. So we have that as one set of issues. The second set of issues is flooding that comes from the side. When the Morris Canal and the Hudson River overflow their banks, as in Sandy, and you get a rush of water coming in from the side. What we did was analysis of future sea level rise. While we had maybe 5 to 6 feet of flooding on the lowest end of the site during Sandy, we anticipate that's going to increase to about 8.5 feet of floodwaters on the site on the lowest end and maybe 5 feet on the higher end. So I want to really go through strategies to deal with those two types of flooding events separately. So go to the next. So let's deal with the heavy rain events. I want to go through those first. Next. Here you can see a plan of the project and a map of the underground piping connections. The buildings are in orange. These blue lines are basically all of the stormwater and sewer connections. All of the roofs, all of the groundwater, including in the grass, on the paving, and the sewer, all go into these pipes, and they all go to one place. They all go into one pipe. And this pipe isn't big enough to handle that capacity. And that's why you get flooding from rain events. You can see from the roof, you get pipe leaders. They actually go back inside the building and then connect to these pipes underground. So there's just too much water going to too small a place. Next. But there's ways you can deal with that. You can divert that water away from the piping system, and you can use natural methods to do that. So these are rain gardens, various types that capture rainwater, and they actually, if you put the right types of plants in them, they can clean the contaminants in the rainwater, filter it, and gradually let it filter into the ground. And therefore you're directing it away from the piping system. And we've worked on these types of projects all over the country. Next. So here's an example. During our walking tour of Booker T. Washington, the residents identified a lot of things in addition to the stormwater things. We talked about how they use the public space. They particularly said that some of these things like the interior fences really didn't make sense to them in terms of the space. And so, next. So this is what we could do, is we could convert some of this This is a very early sketch. As we said, we're only about 30% through the project. We could create rain gardens around the edges of the buildings, capture the water that comes down from the storm leaders, and it would be filtered and cleaned by these rain gardens and diverted away from the underground piping system. And these actually are elevated because there's a high water table, and that's probably true of many public housing sites. So the water can't filter in very quickly. By raising the ground, it gives us additional capacity. And we can work various public amenities into that plan as well. Now, other things we can do is replace the paving that's right now impermeable with pervious paving systems that allow the water to seep through the paved areas. So there's various types of that that we can install, and our landscape architects have worked on this in many parts of the city as well as the country. Next. Other strategies we can use we can use cisterns to capture excess rainwater. And in fact, because of the flooding that took place, the basements of Booker T. Washington are now vacant and basically have very little in them. We could put, instead of excavating cisterns under the yards, we could actually put them in the basements so we can collect rainwater. And another thing we can do is we can actually collect the sewage, because there is this combined stormwater and sewage system in the underground city pipes. So by storing the sewage during a heavy rain event, we can keep the sewage from overflowing out of the underground pipes and overflowing into the Hudson River. And then we can release that water after the heavy rain event is over.